on, but I'm going to need a couple of volunteers. How about you two lovely contestants? Come on up. And how about two folks who have not been prepped on the staff? Yes, I see two hands here, about in red shirt here, and someone from this side. Someone from this side. More interest, more interest. Not seeing that. How about you with your hand the highest? There. Right, yep, you two just turned around. Yeah, come on down. There'll be ample opportunities during the remainder of the term. So now there's still an opportunity for some participation here. I need two people's algorithms that they actually wrote down. All right? Better be good. Thank you.
Preview. It's right there.
OK. Not going to get this back if that's OK. And one more volunteer. All right. All right. These will be very short demos. All right. So we've got 4 of our volunteers here, only 2 of whom I actually know. So let's see, your name is?
I'm Daniel.
Daniel, David. All right, this is Rob, Zmaila, and?
Lisa.
Lisa, David. All right, so I just so happened to go to the supermarket before this example, and this was actually inspired by my 5th grade teacher, who at the time, I'm pretty sure, did not intend this to be any sort of demonstration in the pedagogy of computer science and the ideas behind algorithms, but really just how to teach 10-year-olds how to follow directions. Well, let's see if we can't, though, borrow the same spirit of this, since I was well equipped here to go and pick up some loaves of bread. So we've got some bread for each of you. All right. We've got some jelly here and a knife as promised. We've got a knife for each of you. And lastly, the final ingredients with which to see how well these algorithms performed. All right, so let's see how our 2 volunteers here did. So I'll go ahead and be the advisor. You all should be behaving in exactly the same manner that a computer or a robot, let's say, would actually interpret these as, making no assumptions. All right. Step 1, go to the Annenberg lunch table. Okay. All right, let's start with the other one and see where this gets us. So step 1 here is take 2 slices of bread from the loaf. Incidentally, should have said this before, you have to be comfortable appearing on camera and on the internet as we do this. OK. All right, step 2. Apply 2 tablespoons of jelly on both halves. Step 3, apply 2 tablespoons of peanut butter in the same way. Step 4, join the 2 halves. And step 5, perhaps coupled with a round of applause, have fun. So thank you very much to our volunteers. The sandwiches are yours. So Suffice it to say that there's room for improvement in something like this. And this might seem like a ridiculous visual, but the reality is when it comes time this semester to instruct a computer to do something, you'll be surprised just how often and how bad you are at that when you're doing this, most likely for the very first time. When you're doing this for the very first time. And so among the lessons that will become ingrained over time, honestly, is truly how to think more carefully, how to think more precisely, and in turn, how to express yourself, if you can just take the tables with you, how to express yourself more methodically so that the person hearing your counsel, the person hearing and taking your instructions, can actually implement them correctly. Now let's come back to this notion of numbers and this notion of solving things more efficiently and this notion of dividing and conquering and really the notion of things taking more time or less time. All attention is clearly focused right here, right now, isn't it? OK.
We have an algorithm, too.
No problem. Very nice. All over the internet this is now. All right, thank you to the team. So consider this. Suppose you were asked, and let's pick a volunteer up front here, since you just caught my eye. So we can have this conversation right here. I will hand you $1 million. I will write you a check right now for $1 million. Or instead, you can have a penny today, but 2 pennies tomorrow, 4 pennies the next day, but just for a month. Which would you prefer? All right, so frankly, whenever asked in life to make a choice between something that sounds good and something that sounds stupid, take the stupid thing, because there's probably a hidden lesson in there. And indeed, there is. If we consider this, oh, I just reneged, didn't I? So consider this. Actually, we did come prepared. Can't quite cover it today, but this will get me through the week, I think. So why do I suggest we can't quite cover that? Well, let me just open up something like Excel. Let me say now and just once that Excel is not computer science. But we'll use it simply because it's a nice way of just doing some numbers real quickly. So suppose that on day 1, I were given a single penny. And on day 2, I get twice as many, and then twice as many. Well, I can do a silly little Excel formula here where I just say times 2. And then I can just repeat this, and repeat this, and repeat this, and repeat this. And this is getting tedious, so let me just highlight all the way up to, say, 31 days in a month, and hit paste. And by the time I get up here, you might very well have made the right choice. In fact, just to make this point ever so clear, let's go up to formatting, this too, not computer science. Let's go to currency, OK, just so we can see this a bit more visually. And my God, you banked $10 million from that deal. So 3 weeks to go. So it's quite extraordinary what happens. And what's the relationship here? Well, the actual math behind all of this and the actual thinking is actually the same. Whereas before we were dividing in half again and again. And that allowed us to solve something much faster than with some simple, if naive approach. The implications are the same in reverse. If you actually do something foolishly, or in this case without thinking, the cost can certainly pile up over time. And so one of the other themes in the course and in programming more generally is going to be about the amount of time it actually takes for your programs to solve problems. Every one of us has probably gotten angry at our computers at some point because of the stupid spinning beach ball or hourglass or something like that that means it's thinking or doing something. Well, it's probably not doing it all that well. And once you get to the point of implementing the next Facebook or Google.com, you've got to be better than just linearly searching through all possible pages on the internet in order to find some search term of interest to you. Well, this sort of works in a similar way too. And I mentioned here Facebook. You're familiar with the notion of the 6 degrees of Kevin Bacon, perhaps, whereby you are probably connected to someone else via at least 6 friends. So I might be friends with Alice, Alice with Bob, Bob with Charlie, and so forth. And at some point, one of those people in that relationship is going to know Kevin Bacon, of all people. But what's the implication of that? Well, you can actually feel this all the more these days with Facebook and the like, because even if I imagine something quite simple, suppose I have just 100 friends. Well, that's actually, in Facebook terms these days, actually relatively low, right? But we'll start at that particular point, and I'll see if I actually multiply, let's say, the previous cell up there by 100 again. The idea being, well, if I have 100 friends, Those friends, let's assume for simplicity, have 100 friends, and their friends of friends have 100 friends. How much does this blow up? Well, let's actually do this for 6 degrees up to 6. And my God, by the time you get 6 degrees away, no wonder you know Kevin Bacon, because you have 1 trillion people in your social network. Now, back in the day, a few years ago, when Facebook began only at Harvard and was initially only available to Harvard students and then nearby universities, they actually had a neat feature where they would show you a graph, a visualization of your friends and your friends of friends, and then they ripped that out and removed it altogether. And at best these days, maybe you have some kind of relationship with friends of friends, because to actually transitively continue this out, I mean, my God, you end up knowing everyone on Facebook and more people than there actually are in the world at this point. And so these numbers start to build up both upwardly and downwardly.